Sometimes when we do a job, we get a detailed drawing and solid models of the part and the pieces that we need. And sometimes we only get a sketch on a napkin, or in this case, just a verbal description of what we need to do. And so what we need to do on this part, and this is so we're modifying an existing part, we're going to make 2 clearance holes on the part. They need to be in the middle in this dimension, and they need to be a 1/2 inch off of each edge here. And so we're just going to go ahead and lay that out in the CAM software very quickly. We'll create the NC code, we'll bring it to the CNC machine, and we'll just make the part. So since we didn't get a sketch or a solid model or anything with this part, we just got that verbal description, what I'm going to do before I get to the CAM software is just quickly make a little sketch here. It'll make it a little bit easier for me to do this. So I got we'll call it 5.5 inches in that direction. So 5.5. My width is, we'll call it 0.77. 0.77. That hole is going to be at 0.5 inches here. And the center line distance here is going to be what's half of 0.77, so that'll be 0.385 here, and again there's another hole here. Those are going to be clearance for 1/4-20, so nominally I'm just going to call it a 1/4 inch hole, but it will be slightly bigger than that, 0.25, and we do want to do a counter bore on the top. And I think they specified they wanted that counter bore to be 0.375. So I think that's enough information for me to sit down with the CAM software and get going. One of the things we've done here in the WPI manufacturing labs is we've made it possible to actually use the CAD and CAM software, all the CAD and CAM software we support here, right at a computer that's mounted at the machine tool. And what this lets us do is it lets me very quickly make a part like this where I don't have to go find a computer, I don't have to go sit at my desk. I can simply walk over to the machine tool and get started, create the file, and load it on the machine and send it right away. So today I'm going to use ESPRIT, which is already running on the machine here. And I'm going to just create some geometry. So I go to my Smart Toolbar, I select Geometry, I'm going to select a straight line, I make a line parallel to that x-axis, and I want to make it at 0.385 inches away from that x-axis. I tell it which side. Now I'm going to repeat that process. And again, if I just hit the enter button, it puts in the same distance that I entered last time. I tell it I want to be on this side. And so for my my vertical lines here, parallel with that y-axis, I want to be half of 5.5. And so that's, what's that, 3.75. Sorry, 2.75. 2.75. And as I type that in, it shows up in this distance dialog right here. Type that in, press enter, it asks me which side do I want to be on here. Go ahead and click that side. I want to do it again. Press enter because I want the same distance. Tell it I want to be on this side. Then I'll use this keep tool. And I'll just tell it I want to keep this line, this line, this line, and this line. And now I've made a box that defines the outside geometry of the workpiece. The next thing I want to do is mark where those holes are going to go. And so I find it kind of easy to just make some vertical lines here again. So I call them construction lines, I guess, from having my drawing class back 100 years ago or so. So I'm going to be 0.5 inches away from that one. And I'll go right there. And I want to be 0.5 inches away from this one, right here. And then I want to be 0 inches away from that axis. And so where these two lines intersect and where these two lines intersect, that's where those points are going to go. So I'm just going to create a point. I'm going to create a point at an intersection. I'm going to click here, and I'm going to click here, intersection. Try one more time. There, found it that time. Go ahead and close the point dialog box. I hit escape to make sure I'm not still creating points, and I'm going to select that line, delete it, select that line, delete it, select that line, delete it. And so now I have, I've created the outline of the box and the location where those two holes are going to be. The next step here is going to be to actually draw, I'm going to draw the feature for the counter bore as a circle. It's going to be at this point, and the diameter is going to be 0.375. And so I'm going to do 0.375 divided by 2. And so I can actually do math right here in this box, 0.375 divided by 2, and it draws it right there. I'm going to make another one the same size, and it draws it right there. So now I've drawn that geometry. I've located the center of each of the points, and I've drawn the outside of that, that counter bore that we want to do here. That's all the geometry. That's everything we need to know. The next thing we need to do is we need to create features on here. And I'm actually going to create a feature on the outside of the part, just using the auto chain feature here. So I'm going to go here, go that direction, and come back here. And I don't really need this feature to make my part, but I will use it when I create the stock for the simulation. Next thing I'm going to do is make the chain features that define those counter bores. I'm going to hold down Control and select this one and select this one. If I click the auto chain button, it'll put a chain on each of those. And finally, what I want to do is I want to create a P-top feature to define where the drilling operations are going to go. It automatically knew that I wanted just those 2 points there, so I'm going to hit stop. And now I've got a P-top feature that shows where I want to drill my holes. I've got my chain features that define where I want to put those counter bores so that I could use an end mill to make those counter bores. And I've got the outside of the stock material defined. The next thing I want to do is actually I want to set it up to do a simulation. So I'm going to go to my simulation parameters here. I'm going to click Simulation Parameters. I'm going to create my solid, and so I'm going to create solid stock from an extrusion. I'm going to select the feature I want to use. I want to use this feature, the chain feature that I used for the outside. I want to go 0, positive Z. I want to go, let's call it 2 inches, negative in Z. I want to have 0 offset, so this would make it either bigger or smaller. I don't need to do that. I'm going to add that. I'm going to click OK, and I'm going to click Simulate, even though I haven't created any operations, just to make sure it draws the stock where I want it to be. And so it drew that stock. I can change the color there if I want to. If I hold down this middle mouse button and the Control key, I can rotate it, and that just shows me that I made stock exactly where I want it to do. I can also change the view up here by going to isometric or the top view, which is what we were working in before. I'm going to hit stop. It'll make that stock material go away. But now when I create my operations, I will know that I've made them at the place where I want to make them. The next step here is going to be to create some tools. And so before I do that, I'm going to view the project manager. That shows me all these chain features that I already created. It would show any operations we've created and any tools that are installed here. So I've got my project manager open. I'm also going to view properties. And it makes these boxes, you can drag them to wherever you want them to be on the screen. And so I like to have the project manager on top and the properties viewer on the bottom. So we need some tools. So the first thing I'm going to need to do is I'm going to need to create a spot drilling operation for my 2 1/4-inch through holes that go through the part here. So I'm going to create a new milling tool. I'm actually going to use a drill mill to do this, a 90-degree chamfer tool to do this spotting operation. And so I'm going to select chamfer mill as my option here. I'm going to put it in the tool 6 location. I'm going to call it chamfer mill. Tool 6, length register 6. Over here, it is this shape. There's a bunch of different shapes you could choose from here. The one I have has a little flat on the bottom. My tip diameter is 1/32 of an inch. And so I can actually do equals 1 divided by 32 here. I can then say that my chamfer angle there is 45 degrees. My shank diameter is 0.375. My control diameter, now I could use any, if I go here and look at control diameter, I can use any point along here, which would be where the depth that I wanted to do that chamfering. Since we're going to use it just to do a spot drilling operation here, I'm going to do that 0.375, and cutting length is actually about an inch on this tool. And a lot of the parameters that we put in here are used to calculate the tool path. Some of them are just used to show the simulation. So I've got all that information here, and I've got that tool defined. The next thing I need to do is create a new milling tool. I need a drill, and we'll go ahead and put this, we can put this in the tool 2 location. Drill. And so this needs to be clearance for a 1/4-20 hole. I'm going to go ahead and use an F drill, which is 0.257 inches, so it's basically one size up from our 1/4-20. F drill, and we'll go ahead, leave it at 2 flutes, 0.257 inches, and all the rest of the defaults that it comes up with here are going to be just fine for us. So I've got my my chamfer mill created, I've got my F drill created, and so I'm going to put in one more tool, new milling tools, end mill. I'm going to put it in the tool 8 location, and I'm going to create a 375 end mill. So 3/8 end mill, tool 8 location, come over here, 0.375, cutting length, that's about right actually. This is actually a 3 flute end mill. And perfect. Okay, so I've created 3 tools. I could have also had these previously saved in a template file and just started from that template, but I created 3 tools. I got my F drill, I've got a chamfer mill that I'm going to use for spotting, and I've got my 3/8 end mill. The next step here to do is to create some operations. So the first operation I'm going to do is the drilling operation. I'm going to select my P-top feature. I'm going to come over here to milling operations. I'm going to select drilling. I'm going to start with my chamfer mill because I just want to spot drill that. We'll spin that at 6,000 RPM. And we'll feed it, well, let's see, I don't know how fast to feed this tool for this operation. So I'm going to come over here to my WPI Manufacturing Labs website. I'm going to go to Documents and Links, and let's see, Feeds and Speeds. And so this is one of the tools that we keep in stock here. So I'll go to my drill mill. And so what does it say we want to do? We're in aluminum. So our cutting speed is between 320 and 650 surface feet per minute. Let's see, so my 589 is within that range. And our feed in the Z direction is 0.003 inches per flute. So I'm going to do over here per minute, per revolution, per flute, 0.003. And that'll calculate 18 inches a minute to go in there. We're simply going to drill this. Total depth, I just want to go down a little bit here, so let's call it let's go down 50 thousandths. Starting depth is 0, chamfer diameter tip, nope, 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 and okay. And so it's going to create a spot drilling operation right there for us. The next thing we're going to do with the same feature selected, this time we're going to peck drill. We're going to use our F drill, and I'm going to go back to my feeds and speeds chart over here. back one step here. Drill bits, sizes, feeds and speeds. And so again, we're in aluminum down here. I've got an uncoated steel drill, so I want to be somewhere around 225 to 300 surface feet per minute, so we'll call that 300. And I want to feed over here our uncoated drill. We're at about 1/4 inch. We're down here. Drag this over so I can see the whole chart. We're down here about 0.009 inches per revolution. 0.09 inches per revolution. It calculates a feed rate. And when I get over here, I want to peck. I'll take the default peck increments for it. And our total depth, now we have to go through the part. I don't know that I measured that through thickness. Again, when the designer hasn't done all the design parts, sometimes you have to make measurements on the part. But we're going to go through the part. It is 0.247, call it 0.25, or 2.25. 2.25. Starting depth again is 0. Use chamfer, no. Tip already included, no. That means it will feed so that the entire drill gets through that part. So that should cut through the part all the way. All right, so we've drilled it. The next thing I want to do, click OK, is let's just go ahead and simulate that. So I'll go to my isometric view. It looks a little bit cooler. I'm going to step through the simulation. So my chamfer mill has come in and wiped out the part. That's not what I meant to do. But let's just let the drill finish. So it looks like the drilling operation works just fine, but there's a problem with my spot drilling operation. If I go back here to operations, click on that first one, I see that I put my total depth to be 0.5 instead of 0.05. And now we'll go ahead and simulate again. And look, it made a spot drill and it drilled through the part. Perfect. And so since I've got a 375 end mill in there and the counterbore diameter is 375, I am simply going to plunge, and he asked me to go 1/2 inch deep here. So I'm going to take my tool, I'm going to take my P-top one more time. I am going to go over here to my milling operations, my drilling operation. This time I will again drill. I'm going to select my 3/8 end mill. For that tool, we can go 6,000 RPM with this tool, 0.0006 inches per minute. We will simply drill in. Our depth is going to be 0.5 this time. And starting depth 0, all this stuff works. All right, okay. And now we'll simulate the whole thing. So I got my 375 counterbore, I got my through hole all the way through. Go ahead and hit stop, do file, NC code. If you're at WPI, you can use this network drive here. At WPI, you can use our network drive and use our post processor here. Post. I have a post for the mini mill. Say OK. OK. And so it's going to create my code. And the next step will be to load this code onto the machine tool. To load the code on the controller, it's pretty simple. We're going to go to List Programs. We're going to select Receive RS-232. Over here in my NC editor, I'm going to go to Tools, WDNC. I'm going to select this HAAS SRS file that we've saved all of the settings that we need to do this already. And so I'm waiting for data, ready to send, click play, and serial receive done. So this is a really short program, so it uploaded really fast. I hit stop here, close that window, sure thing. Go ahead and close this window. And so the joy of doing it on the computer that's right at the machine is that if I decide that I want to change something, all I have to do is pivot my feet. I've got the program open right here. I can watch the simulation if I want to see what's going to happen. And I'm right at the machine. Now the next thing I got to do is I'm actually going to set up the tools to do this. So I'm just going to walk over to the tool setting area and go ahead and do that. And so I'm going to use collet holders for the end mill and the drill. My collet holder in the fixture here. I'm going to take my collet, press the nut onto the collet, make sure that it's securely in there, put it in lightly, put my drill in the collet, and hit it with the wrench. Alright, so that one's good to go. I also need to set up a 3/8 end mill. The one I grabbed out of the drawer was a 1/2 inch end mill, so I'm going to actually grab a 3/8 end mill. That's something to be careful of. Just because it's in the space that's labeled 3/8 end mill doesn't mean that it is a 3/8 end mill. This one is in fact a 3/8 3/2 end mill. I need to get a collet, push the nut on the collet, make sure that it's secure, put it in here, and as always when we're setting up an end mill, we want to hold it in that collet as much as we possibly can to get the best holding force and to reduce the lever arm for any deflection forces that we might have acting on it. Put those tools away. I've got my drill, got my 3/8 end mill. We keep these little chamfer mills already set up in holders. So I got 3 tools. I'm going to actually use a tool cart. Put my 3 tools in the tool cart. And wheel it back over to the machine. In this facility, we have over 1,600 different users every year, and it's never a good idea to assume that that vise is square on the table. So the first thing I'm going to do is I'm going to jog my indicator down. I'm going to bring it over so that it makes contact with the part, with the back vise jaw. Get that set right there at 0. And I'm going to jog back and forth on X and just make sure that my vise is relatively square here. So that looks like it's good enough for these parts. I'll go ahead, put the tools in, set the work offsets, and so the next step is going to be to load the tools. So I'll go to the Tool 2 location, T2, MDI, ATC forward. If there was a tool in there, I'd take it out. I'm going to go ahead and put in my F drill. I'll press and hold the tool release. Put my tool in, let go, make sure that it's securely seated and that the dogs line up with the slots in the tool holder. Next tool is tool 6, T6. MDI ATC forward. That is my 3/8 chamfer mill. Again, press and hold tool release. Let go, make sure that that tool is securely seated. And T8. MDI, ATC forward, 4x3/8 end mill. Tool release, and let go. All those tools are in there. We'll want to set the tool lengths for those tools. I'm going to use the tool probing macros edit F1 visual quick code because this is an older controller. Tool setting. I'm going to do tool setting, length only, random tools. And so it doesn't actually do random tools, it does specific tools, it does the ones that you tell it to do. But I want to do tool 8, I want to do tool 6, and I want to do tool 2, and I'm going to enter zeros for all the other spots. And send that to MDI. Next step in this process is to fixture the part. And since we're going to drill all the way through this part, I don't want to set it down on the vise. So I've got some parallels here. I'm going to slide in. I've already cleaned the vise and checked for chips there. I'm going to put the workpiece on top of those parallels. I'm going to push it down on it, and I'm going to tighten that vise. What I don't want to do is drill through my parallels, tap them out with just a piece of aluminum that was a little bit thinner than my stock material. And now that's held in the vise. It's friction between the vise jaws and the aluminum part that's holding it in place. I'll be able to drill all the way through that without drilling into the vise. So since we set our work 0 in the CAM software to be the top center of the part, I'm going to use probe center of block from center to set this up. Again, on one of the older controllers here, I'm going to go to edit, F1, down to visual quick code, Spindle Probe 1 through 9. I'm going to come down here, probe center of block, start from center. That's the one I want. My work offset is 54. My X width, remember, is 5.5. My Y width was 0.77. And my Z depth, this is the distance that that tool is going to go, the probe is going to go down in order to touch the side of the part. Let's just do 0.75. And I need to do, cancel, minus 0.75. And that will allow the tool to come down 3/4 of an inch and touch the sides of the part. And enter. I'm going to use MDI. To run this probing macro, we're going to tool change to tool 10. We will handle jog the probe so that it's visually centered above the part. And again, it just needs to be eyeball centered above the part. Then we can close the door, go to MDI mode, and run the macro we've set up. And so since we're running this part at WPI, I'm going to go ahead and check off my boxes in my Safe Operator checklist. So I have simulated in the CAM software. I've set the tool offsets. I've set the work offsets. Next step is to simulate on the controller. So I'm going to go to Memory, Setting Graphics, Cycle Start. And so it looks like I need to F2 to zoom out. Home. Enter. And I'm going to cycle start that one more time. So, drills 2 holes. And everything looks good there. So I've simulated on the controller. I'm going to reduce my rapid speed. I'm going to do 25% rapid. And for each tool as it approaches the part, I'm going to stop and check that distance to go. So we're ready to go. We'll hit current commands, get the distance to go coordinates up on the screen, and we're ready to start this part. So the first tool it should change to should be that chamfer mill. And it should be coming down about ½ an inch away from the side of the part. That looks good. And in the center of the part. And it says 0.8787 right now, and it's going to Z equals 0.1. I think that looks reasonable too. The coolant will turn on that next line of code. And so what I noticed right away is that the coolant didn't turn on. I'm going to need to fix that before the next tool runs, because we definitely want coolant on that F drill. I'm sure the reason the coolant didn't turn on is because the last person who washed down the machine left the washdown hose set instead of the coolant to the spindle. So as soon as we do the check distance to go, we're going to go ahead and fix that here. And so I'm at about 0.3206, and that looks pretty reasonable inside there. I'm going to go check the coolant, make sure it's on the right hose. I'm going to go ahead and stop the spindle. I'm going to turn that coolant off and adjust it just a little bit. I like to turn the coolant off before I open the door to adjust it, so that I don't get too wet. All right, coolant on. That's on that drill. Clockwise on the spindle. And I'm going to go ahead and cycle start. And so this final tool that's going to come in is going to come in, and it's just going to feed slowly down into that existing hole to get us our 0.5-inch deep counter bore. So this is going to go about 1 inch. I'm again going to adjust the coolant, and I'm going to make sure I get a good, keep the door mostly closed. Make sure the coolant's shooting down the flutes of that tool. Clockwise to start the spindle. And cycle start. And so there we have it. With about 30 minutes of setup time and about 5 minutes of cut time, we've got our finished part. We started with no solid model, no drawing, not even a sketch of this part, just a verbal description and the workpiece material to start with. You know, for more tips and tricks, you can subscribe to this YouTube channel, or you can check us out at CNCQuickGuide.com.